All right, this is problem number 4, and I want to make sure that I set up everything correctly. So here's the deal. This is actually kind of a trick question, and it takes a little bit of diligence to get it done. So let me just kind of begin here. So we have an initial height of r, and then we wind up here. Okay, and I'm actually going to measure this angle here, and I'm going to call it theta. And I just want to kind of denote that this height here, when we do the trig, is in fact r times the cosine of theta. When I draw a free body diagram of the forces, I have a normal force on the kid. I have the kid's weight. And it turns out these two force components, when we do the trig, this is going to end up being w sine theta. And this will be w cosine of theta. And so what we're going to do is we're going to set up all the possible physics that we can without any expectations of where the problem is going to go. Basically, we're just going to write down all the laws that we know how to write down, and we're going to hope for the best. That's kind of how the AP physics works sometimes. So in this case, we have the normal force. We have the weight, cosine theta, competing with the normal force, and the effect of that is that the kid moves in a circle. Now, the other thing that's happening is that the kid is falling from a height mgr to a height mgr cos theta, and he acquires some kinetic energy in the process. Now, right when the kid leaves the ice, the normal force is 0, and we've written our circular motion or energy conservation equations, so we can say mg cosine theta equals mv squared over r. And let's do a little bit of isolation here. I'm going to isolate the expression m1/2 mv squared like this. So I want to just say, I'm just going to note that mgr times the cosine of theta equals mv squared. And this actually allows me to do a nice substitution in for my kinetic energy. So I'm going to write mgr equals mgr cos theta plus 1/2 mgr cos theta. And this actually is going to give me mgr equals 3/2 mgr cos theta, and a lot of things cancel. So what I'm going to end up getting is that the cosine of theta is 2/3. Now, if I want to know the height that it exits at, that's going to be r times the cosine of theta, which is r times 2/3. So h is 2/3 r. All right.